Alright, we're still working on computing limits both numerically and graphically, and I have the limit as x approaches a negative 2 of the function 3x divided by 2 minus the square root of x plus 6. And you can see when I put a negative 2 into here, a negative 2 plus 6 is 4, the square root of 4 is 2, 2 minus 2 is 0 in the denominator. I'll have a negative 6 in the numerator, and negative 6 over 0 is undefined, and that's why I put this little slash in here. But again, a limit is not what the function is particularly at that value, but what it approaches as it approaches from the left and the right of that value. So this is fairly complex, and I'm going to use the use of my calculator to come up with my table. And I have a calculator right here, a calculator simulator, and this works on either on a TI or a Casio. They're a little bit different, but they work exactly the same way. Just give me a few seconds to load it up. And I'm going to go to graph. Actually, I'm going to go to, I think I can go to table on this one. Oops, I got to use this function. Okay, where was table? Over here to the right. Execute. Okay, and so I have a table, and I'm going to put in my equation here. And it's going to be 3x divided by parentheses 2 minus the square root of x plus 6. And then use this, get the outside of there, finish my parentheses, press execute, and it looks just like I want it to be. That's what's nice about the Casio. And I'm going to create my table first of all, so I'm going to press an F6. And I'm going to put in my values. Again, I want it to be what it approaches. So if you take a look at my table here, I have a negative 2.1, a negative 2.01, a negative 2.001. And I encourage you to use this on your calculator. Again, you can use this on a TI or a Casio. And so I'm going to enter in this first value, a negative 2.1. And I get a negative 250.4, so that's what I'm going to write here, negative 250.4. Back to the calculator, and then I'm going to go down here. Maybe what I'll do is I'll put all my values in here first. Negative 2.01. Enter, a negative 2.001. So I'm approaching a negative 2 from the left. That's why I chose those numbers. Yeah, wow, and let me enter this next in here again. I think that's what I had first, and let me go down to the next line. There we go. And you can see my numbers are getting very negative. So over here I had a negative 2,410. 2,410. And then my next number was even bigger. It was a negative 24,010. So what's happening here, as I'm coming to a negative 2 from the left, I'm dropping. So if I'm looking at this, here's my graph. Here's a negative 2. I have an asymptote at negative 2. Because I have division by 0. And I'm headed right here, as I'm approaching this, I'm headed down, and I'm headed down quickly. Alright, so now I'm going to put those values in here and take a look at the next values. And I'm going to put a negative 1.9 because I'm approaching it from the right. 229. 2,389. Oh, it's not going to let me do that, so I'll put it up here. A negative 1.999 and 23,989. So I'm just going to, so I can see these. 229.41, 2,389, and 23,989. And so as I'm approaching this way, I'm going, as I'm approaching over here, I'm going up dramatically. Okay, so we're headed in two different directions. You can see by the graph and see by the table. So it is not headed to a specific value. They're headed in opposite directions. So what we write here is we write D, N, E. And what we're saying is the limit of this function as it approaches x, as it approaches a negative 2, both from the left and the right, does not exist because we're headed in two different directions. D&E stands for the words does not exist. And you can see that both from the table and the graph.